What is a cloud computing or Amazon Web Services? Amazon Web Services is one of the cloud computing. In general, what is a cloud computing is like? Uh, Very often we are too used to have infrastructure in place. We have big machines where we see, where we work, and the servers are also present there. When you want to install a software, licensed software, we buy the license, we install it on the machine. Uh, if we need to do a setup, if we want to do an installation of the OS, we sit down and then install it on the machine. If I want to increase my RAM for my machine, we install it on my CPU directly. So these are added cost and time there. For example, if I have to install my OS, I need to bring in an IT admin who does the job for me. If I have to increase my RAM, I need to bring in an IT admin who does the job for me. When I say just the job, is not just installing it, it is first step is probably going to the market, getting the RAM. Going to the market could be an online market also, or a procurement site where the RAM has to be ordered. The ordered RAM has to reach the location and it has to be installed. All this while the person has to be available. Let's say if I want it to be in midnight, then it's not going to work out. These are the major constraints that we have. We move all these to a cloud, right? We are getting a virtual machine which we can connect via various other ways, a remote desktoping, a putty, or whatever ways there are there, VNC servers, etc. The machine sits somewhere else and we connect to it. What are the advantage here? The system is out of the network. Anybody can access it. If I want to increase the RAM, if I want to do anything, it is taken care uh, outside our infrastructure setup. Somebody else would do the job for us. The hard disk increment, and most importantly the disaster management and other stuffs, like how do we ensure that the hard disk doesn't crash, how do we ensure that we have backup data if the hard disk crashes. These are the headaches that a common IT team would have had when we have an in-house infrastructure. All these are addressed by outsourcing this concept to a cloud. We have various cloud vendors here, Amazon Cloud, Oracle Cloud, Salesforce Cloud, etc. All these people, they take the infrastructure with themselves. They have a monster sitting there out of which one piece comes to one vendor, another piece goes to another vendor. Typically, they call it a multi-tenant environment. However, each customer cannot access another customer's data. That's the architecture beauty, because everybody would have a token of their customer ID or org ID, and the information is not shared. What is the advantage? The backup mechanism, uh, the IT mechanism, or cost saving, quick. Anytime I want to increase my RAM, I can do it in next 5 minutes because it's on cloud and it's 24/7 always available, and it is without any manual effort being involved. That's cloud computing for you. The second topic is, why do we need AWS infrastructure? Why can't just in-house infrastructure? There is a lot of things where we spend our money on. Instead of spending money on my cloud infrastructure, at the end of the day I won't even own anything. Why can't I spend it on my own resource and keep it in-house? Maybe we are able to get a less cost resources as well. The answer for that is a small story. Uh, let's say there are two guys, pick Ramesh and Suresh. They start a business in a small 1 BHK uh, apartment, right? They have a small 1 BHK apartment or 2 BHK apartment, and then they start their business from there. It's pretty simple. Both have just one computer there, and then With that, they could take care of their network, and their customer base is 10 each. With time, their business is really picking up. Let's say Ramesh is doing it with cloud, Suresh is doing it with in-house infrastructure. For their customer base of 10 customers, they all require probably a 4 into 4 square feet of land for keeping their infrastructure setup, which is the database, servers, computer, etc. Over the period of time, the customer base increases. 10 becomes 100. The 4 by 4 infrastructure of Suresh becomes a small room. And for Ramesh, who is still using a cloud infrastructure, the space remains the same. Another year goes by, the 100 becomes a lakh, a million. They now have a million customer. Now, Suresh needs to spend in at least another 1,000 square feet of land for keeping the servers, the database, and now that he's a million customer guy, he also needs to spend space, time, effort in doing a backup data for his customers. He need to have another 1,000 square feet of space, infrastructure, and an IT team to take care of the database, servers, and his infrastructure. Meanwhile, Ramesh is pretty cool. He's continuing to increase his usages in the cloud environment. At this point of time, if you look at it, if these guys want to increase the customer data, customers from 1 million to let's say 1 billion customers, it's probably not going to be feasible for Suresh because the space is a big constraint there. Data management is a big constraint there. His IT team management is a big constraint there because if one of his team leaves, then he has to find a replacement immediately because he has a vast customer base there. But for Ramesh, it's a cakewalk. He has to just do all these things with a click on the cloud console. That's the reason why we need to have this infrastructure. The scalability, the reliability, and the backup plan are amazingly easy and very stable, which is almost impossible for anybody to do it at that pace, at that cost in an in-house infrastructure. With that in mind, anybody who wants to scale up at a rapid pace would need to have his infrastructure at cloud because that provides an opportunity to go outside a network. We can immediately start checking all those things on your mobile and stuff like that. Anything is possible. Now there are three major, I'm just moving to the third topic there, right? Different cloud services available. There are a lot of cloud services available. These three are the most popular and most basic cloud services that are available. Step one is infrastructure as service, that is IaaS. In this case, we provide only the infrastructure. We just provide a hard disk, RAM, and a virtual machine, and then the customer can install whatever they want there and then go forward with that. Still chargeable. The charge is for the hard disk and the RAM involved. PaaS is a platform as a service where a platform is pre-installed there. It could be a Windows platform, a Linux platform, whatever it is. So the customer may not have everything that he wants. However, he has everything that is basic already available for him. It's almost like I join a job, I get a laptop in front of me. It's a PaaS. I have everything pre-installed there, but it's not end of the thing of the software that I have to build. If I have to go do like that, I can do it. Software as a service is not only just the platform, even some of the softwares are licensed and available there. Imagine if I have to buy a license of a software which is $1 million, I cannot afford it. However, if I go and get a SaaS instance of the software, then I have to just pay only for that 1 day or 2 day where I have to use it. The cost goes down immensely and we can go ahead and start using the licensed versions. That's the beauty of SaaS. SaaS is software as a service. You may not have a lifetime license required to use it. You can just get a license and then use it as you need. That's it. One of the basic things that we do in AWS, there is something called EC2 instance. That's where you create all this IaaS, PaaS, SaaS, etc. That's an instance we call it. It could be a Linux machine instance. It could be a Windows machine instance. That will provide us an IP address for us to talk to the machine. Typically, we have got a virtual machine available for us. EC2 would have its stop, terminate. I can start an instance, I can stop it. Stop is equivalent to a pass. The instance has not died yet. However, the data that we have there is still stored, but we won't get charged for the instance usage. The usage is per hour basis. If I start an instance and use it for 4 hours, I have to pay only for the 4 hours. For the infrastructure, for the platform, and also for the software, only for the consumption based charges. But however, if I don't terminate it, I may still get charged for the hard disk. The hard disk charges are almost equivalent to something that we don't have to worry about. It's like if I have to use a huge GBs of data, then it gets charged. So we are good with passing an instance without terminating it, given the advantage that we can resume it back. However, every time you start an instance, the IP address of it would get changed. To avoid such things, we have to go for an elastic IPs, which I will cover a little later. In addition to the instances, we can start an instance and we can have our database installed there, or we can use a RDS database, which is a pre-installed databases available in Amazon. RDS could be Oracle database or non-Oracle database or any database that we know, and that is pre-configured, and the data could be stored as a snapshot and then retained. This is extremely useful because we don't have to run a machine which keeps the database there, because there are some basic things like multi-tenancy and auto backup, etc., which are part of the database management or automatically taken care in RDS instance. The disadvantage here with respect to an instance, EC2 instance, is that we cannot have anything else running on an RDS machine except for the database. AWS provides a security, multi-layer security. We can have a security in which we can block and allow only a certain port. To say, like, I allow the user to access 7011 port, but I don't want him to access 7001 port. That way, a user can access the application, but not the console. Right? If we have the application and the consoles running on two different servers nodes. Also, it can allow the users to use access from only a set of IPs, predefined set of IPs, which we can achieve by having a VPN connection. On top of these two, we can also create our own firewalls by purchase firewalls from the Amazon market and put it on our applications. The security is very robust. That way we can, it's almost like if I want to make this public cloud as almost like a protected or private cloud, we can do it with ease without requiring any effort, just by using the pre-configured information. Another great advantage of the Amazon is that the auto scaling. Any point of time, if the user load increases, right? Let's say I have 5 users for my application, and if it has to become 10 or 100 or 1000, then I have to increase the number of instances of the servers. that can happen. And auto scaling also means scaling down and scaling up. If my user are coming down from thousands to 10, then I can scale down as well. The nodes will be managed. It also takes care of serializations, passivation, etc. These are all configuration. We can select a EC2 instance and then choose to add max node limit for it, and then it will automatically scale up or scale down. And the last but not the least is the security configuration. This security configuration is within the AWS instances as well. For example, let's say we are the development team, and within the team we have different guys. One guys who are taking care of the uh, model, one guy who are taking care of the UI, and we don't want the UI guys to use the model instances, etc. That we can do by configuring the access for the user members to the instances. Say like this user have access only to this. Usually to access the machine, PPK files will be generated. We can have a set of PPK files access only a set of instances. That way there won't be an overlap. These are the common things that a beginner would need to have, right? There are more things there, but at to the starting point, these would help. How to create. Another thing that I probably missed here is that uh, creating images, restoring. We need to create images for the instances so that it's very similar to I have Linux box. I want to create an image of it so that if something has crashed, I want that to be the backup plan. Like that, we can create images for our thing, and then using that image, we can resume my instance. Snapshots are equivalent of an image for an RDS or a volume. The concept of a volume is that I want to just increase my hard disk space of an existing EC2. Then we can create a volume and then attach that volume to the EC2. If I want to increase the memory, then we can go for a larger size of the machine. Usually we have micro, small, medium, large, etc. That is based on the amount of RAM available for that instance. And we can create user access, we can create user groups and then map groups to the users, we can manage passwords, etc. It's available under the console for admin users, admin privilege users. Cost management is another thing. We can check how much we are charged for the EC2 instance over a day, week, month, etc. And we will also be given a wide range of things like how much is spent on EC2, how much is spent on RDS, how much is spent on the volume, how much is spent on the tax, etc. We'll also be charged on the number of hits that we get. That will also be mentioned there. Elastic IP, yeah, I mentioned about it. I am coming back on it now. Usually, whenever we stop a EC2 instance, the IP of the instance would be lost. Let's say I create an instance, I share the IP with all my users. I stop my instance for some reason, I resume it back. I don't want to inform all my users that the IP has changed. To ensure that that is not the case, uh, we have this elastic IPs. Elastic IPs would not lose their the value of the IP even if the server starts or stops, and any live or product application should have its own elastic IP. There is also a private IP which is constant, but then that is accessible within the Amazon network. Within the network only we can use the private IPs. Also, the AWS console comes with a mobile app so that if we have to use something while we are out, if you have to start or stop an instance, we can do it from our mobile itself. It has Android, iPhone, and other apps. It's just for administration purposes. That's the basic thing that I planned for. If you have some specific thing that you are looking at, you can ask me. I'll go over that.
No, no, Shankar. Yeah, it was. Hello?